Hey guys, Zong here, back with another math video. Today we're going to be doing 2014 AMC 12A problem 20. It's a geometry problem. Pause it if you need to, read the question, and without further ado, I'm going on to the solution. So the triangle BAC, with the angle BAC equals 40, AB 10, AC equals 6. Well, obviously, to start out, let's just draw it out. So let's have that be. Let's have the lower left point be A. This point be C. See if I can. Alright. I think that's okay. Let me just move this over here because I need this for later. Okay. BAC is 40. That's not really 40 degrees. AB is 10. AC is 6. Alright. Points D and E line AB and AC respectively. So let's say D. Let's just say this is D. This is E. Let's see what happens. Minimum possible value of VE plus DE plus CD. So BE, which is if I can draw it, that would be BE plus DE plus DC. So that distance. What is the smallest possible value of that? Okay, when you run into a question like this, where you have to find the minimum possible value of a certain distance between these points, you usually want to actually try reflecting. You want to try reflecting the shape, and I'll show you why. So for now, let's not draw that line, so it won't get too messy, and let's reflect the shape across AB. So see if I can copy this, right? And okay, that's something. And then that's not the only time we're going to reflect it. I'm going to reflect it again. How do I do this? Oh, I have to flip vertically. Reflect it again like this. You'll see why. And one more time. Sorry, just gonna do that. So there we go. So we've reflected the shape quite a few times across AB, and then we reflected that across AC, and we're gonna see why. So that's A. Let's this be C1, this be C2, because C is the obtuse angle of each of these triangles. Of course, this is B2, but that won't matter very much. So what happens here? Let's draw D, because you just reflect it across this, so it's D, and E is still the same, and yeah, so that looks good. And let's try to see what exactly I did here. So we want to find the minimum possible value of essentially BE plus DE plus CD. So BE is this, right? But instead of drawing the next line to D, since the next portion is DE, we're going to draw it to the second D, because since it's reflected, the distance is equal, right? So I should mark it down. This is D2, I guess. D2 is equal to DE. D2E is equal to DE because, of course, it's just a reflection, so this is just equal to this. And, of course, the next one we're going to draw is from D to C. And instead of D to C, we're going to draw D2 to C2. Because since it's a reflection, D2 to C2 is essentially equal to D to C, right? So D to C is equal to this, and since this is a reflection, it's equal to this. Hopefully you can see where I'm going here. So essentially, this quantity, BE plus DE plus CD, is equal to BE plus D2E, since it's a reflection, plus D2C. So essentially, it's you put down E and D such that you make a path between B and C2. So there's a path between B and C2, right, along this path, and that's the distance. Well, the shortest path between B and C2 is just a straight line. And that's, since we want to find the length of this path, the shortest length of this path, mind you, the shortest length of that path is just going to be a straight line. So actually, what we want is, in order to find the shortest length, we want E to be actually right here, and D2 to actually be right here, and the shortest path will just be BCT. So shortest path BC2, alright? And notice how we figured that out with reflections. So now how do I find this, the length of this path? Well, actually it's not too hard. So notice how this angle is 40. We still haven't used that information yet. So 40, since it's a reflection, this angle is 40, right? And since this is also C2AB2 is a reflection of CAB2, this is also 40. So totally this angle, of course, is 120, right? The length of this is 10. AB is 10. I see where you're going with this, right? AC is 6, right? AC is 6. So AC1 is 6, and AC2 is 6, because they're just reflections. So now we have a triangle which sort of looks like this. If you can see it. It's C2, A, B, 6, 10, 120. And we got to find this length, or this length. So we can just use law of cosines. So BC2 equals BC2 squared equals AC2 squared plus AB squared minus 2 cosine 120. And if you calculate that out, you get BC2 squared equals 96, since you just plug these values in. BC2 equals 14. So the correct answer is D, 14. And notice how we did that using reflections and law of cosines. This is law of cosines, I forgot to mention. Okay, well, hope you found that enjoyable. I'll see you next week. So totally you're going to get n terms, because there's going to be n of these sub-expressions. See, there's 2 sub-expressions here. So you're going to get n of these terms, and each term inside the resulting expression is going to be the product of these n terms.